Hey class, it's Dr. Beloff, and I have created a very quick, I hope, tutorial here for you. And effectively, this idea came from a question that was just asked on the Ask the Professor forum by a student in regard to the relationship between the net present value, internal rate of return calculations, and risk adjustments. And we talked about risk adjustments in our narrated PowerPoints, and also in our last exam preparation class. So I thought there's probably a little better way to clearly illustrate how this works dynamically. And so I'm going to attempt to show you that. This is what you are seeing in front of you is the solution that I created for Zellman's problem 21 in chapter 7 that I had posted the other day as a tutorial. And I'm going to just build on that and take this a little bit further to illustrate how we would adjust these values and how for the perceived risk of the project and how that would impact the choice of a project. So if you look here, you're looking at line 54 through 80 and right here to here. This is the bottom section of the problem 21 where I solve for net present value and internal rate of return. So I've not changed anything from the tutorial that's sitting on the course set right now. So what I'm going to show you here, I'm going to come down here a little bit, and I'm going to show you what happens when we want to modify, or we want to effectively add a risk adjustment to a particular project or projects, and how that impacts, or how it would potentially impact, the choice of the project. So again, we're starting here. Let me go over here. These are the values that we had where we solved solve the problem with a cost of capital of 8%. Okay, and if you go over here, you'll see and that's right out of the textbook. We used 8% as our cost of capital, and hence our discounting factor. Now, let's come down here and I'll show you something. I've added this. This is new to the tutorial. This box here that's largely in this pumpkin color, and you can see that option A, which is the option I solve for here, that option A simply has the values that were copied from here and here. So nothing's changed right now. Okay, that's just a recreation of what is already there. And I've added two hypothetical projects here. Option B and C. These are I just made these up, but to show you how this might work in practice. So option B is a second project. It has a net present value. We presume we've done these calculations offline, and that project returns a net present value of $75,000 and an internal rate of return of about 9%. And then option C has a net present value of $50,000 and a internal rate of return of about 8.5%. So under normal circumstances, if we have the capital available, and our rule of thumb was that all projects that generate a positive net present value would be approved and we'd be funded, we'd fund all three of these projects. No question. They would all have exceeded 8%, consider 8% our hurdle rate. Anything below 8% internal rate of return, we wouldn't pursue. Anything above 8%, we would. So in a world where these projects had equal risk, and we were not going to risk adjust our projects in any way, shape, or form, then we would fund all three, assuming we had the money to do that. Now let's take a second step of sophistication and say that we look at these projects carefully, and we realize that actually some projects are riskier than others. In fact, I've just, again, arbitrarily said, option A, the project that we already solved for, that has a high risk associated with it. Presume it's a new project. We've never done this before. And so we're a little uncertain about that. And then let's look at option B. I've assigned this, again, arbitrarily a risk factor of medium. Okay? We feel reasonably confident of our numbers, but again, maybe we've only done one of these projects similarly and we're not feeling very confident. And option C, we perceive the risk to be low. We've done a bunch of these. We've built 20 surgery centers before. There's not too much we don't know about surgery centers. Well, now, let me show you one way that you can adjust for the perceived risk. One way to do it is to say we're going to assign a higher cost of capital, i.e. a higher discount factor, to the high project. So let's say we're saying, you know what, instead of 8% as our hurdle rate, which is again right here, that's what we used, we're going to assign a factor of 10%. I'm just going to write that there. All right? And so I'm going to go back and I'm going to recalculate this net present value calculation in the internal rate of return using a discount factor of 10%. Well, why? Because we said we're adding 2% as sort of let's call it a risk premium because of the perceived high risk of the program. So I'm now going to go right here, and in the formula in Excel, you'll see right there, that's where the interest rate is specified. See, it says 0.08. So if I want to change the calculation using the Excel function, all I have to do is use 0.1 up. And when I hit enter, you'll see the numbers change. Now, this is interesting, isn't it? Ignore these numbers over here, by the way. I'm just going to eliminate those for a minute. So now what we found out is that project, because we've risk adjusted it and we've added a higher cost of capital, we've adjusted for the higher risk, this project now has a negative net present value of $5,110, and the internal rate of return has gone to 9.9%. So you see that very easily that project went from looking like it was the best project of the three, it was going to have the highest return, to the lowest. And in fact, if we stuck to our rule that every project has to have a net present value that's positive, then this project would move from being the most desirable project financially to the least desirable project, simply because of our risk adjustment methodology. Now, I won't show you this, but we could do this risk adjustment with option B. We could say that option B is medium risk, and we're going to use 9%. I'll just put that in there. And I won't do the calculation, obviously, but what you could do effectively is, sorry about that, 9%. All right, that's not going to work. But let's just say 9%, and that could be 8%. And we could do that. So we can actually have a risk gradient or a risk range. I'm going to go back and fix this for a second so we can just show it properly. We literally could do something like the following, right? 9%. And if we had 3 sets of calculations here, we only have 1 set up there. Sorry about that. Try that one more time. Yeah. You literally could set up a gradient that said for projects that are of low risk, we're going to use a cost of capital of 8%. I'm just going to put COC here. Cost of capital of 8%. This is the increment, incremental difference. This could be a 1% increment. And then, of course, there'd be no increment here because that's arbitrarily what we decided to do. So you see over here, we've come up with a fairly, sorry about that. We've come up with a fairly simple but quite illustrative methodology for showing how we would risk adjust capital investment projects of different risk perspectives or subjective risk assessment, if you will. So again, now, just illustrate that calculation before. Let's say that someone said, no, you know what, we want to add 3%. We want a cost of capital of 11%. So we're going to change this to 3%, like that, because this project is just scaring us a lot. Well, we can go back up here to this calculation, and instead of 10%, I'll make that 11%. You see what's happened is that as we increase the cost of capital here, then the project looks less and less desirable because of the way we've adjusted the formula. So now you can see that risk adjustments are related to net present value insofar as we're able to alter the cost of capital. And when we alter the cost of capital, we change the discount factor. The discount factor will move the net present value in one direction or the other. It also adjusts the internal rate of return. If you go over here to the internal rate of return, okay, that is now, let me see, hold on a minute, let me just see if this is correct. So you notice the internal rate of return doesn't change here, but what that means is that our internal rate of return here is now 11%, or I'm sorry, let me back up. Our cost of capital is 11%. Our internal rate of return is only 9.9%. So you can see that we would be losing, we would be wasting capital. We would actually have an internal rate of return that's lower than the cost of capital. We wouldn't fund this project. So I'm glad I got that straightened out in my head. Hopefully that made sense for you. So you can see that how easy it would be once you have these projects laid out and you had them properly priced and you had them properly calculated in terms of net present value, that by agreeing upon adjustments based on risk, we can go up here and alter the rate and the net present value will constantly change. Okay, if I wanted to go back and make this 10.5%, let's say, and let me do that so you can see it. I can go up into this risk formula and just adjust that and put 0.5 there, 10.5%, and you see how the number changes. Okay, so hopefully this was worth, well, 12 minutes of your time. Sorry about that. It just takes a little longer than I'd like it to take. But in any event, hopefully this was useful for you, and there'll be a question. I'm not going to make you change the rates specifically on the exam, but there will be a question regarding the application of risk factors to a capital investment project. So hopefully you'll find this real useful. So thanks very much for viewing this video. Thanks.